Maybe some of you have experienced the frustration at some point of listening to this sort of analysis or reading about it in a textbook and saying, yeah, but when I try to draw it, it doesn't work for me. I try to draw carbon monoxide, I can't do it. And I try to draw things with negative charges, and I don't know what to do with Lewis dot structures for that. Or I try to draw ozone, O3, and they tell me it's not a cyclic molecule, and I can't do that either. Well, that's normal. And to help solve that, they have some methods. I mean, the molecules exist. We know they have their shape. We know they have their charge. And sometimes the Lewis dot structures just aren't perfect. So we do the best we can. And here's how. We apply something called formal charge. We can assign the charge on any atom and any substance and analyze it in detail and come up with a structure that it looks the closest to reasonable. That's about the best we're going to do. The one we have already drawn here is the carbonate dianion. We're going to analyze it and see how that's CO32 minus. Let's start with something. There it is, ozone, O3. Well, oxygen forms two bonds. It's just not going to work. You know, you try it and it just won't work. So let's draw something pretty close to it. This right here would be a garden variety oxygen. Two bonds, two lone pairs. This one here is not. It only has one lone pair and three bonds, and this one's not either. We can take a look at this, at what the charge on this one would be. Now it wants 6 valence electrons. Let's not consider what it overlapped with and it shared. Let's see what its formal charge is on it itself. That means we're going to draw a line right down here and assign 1 electron to each of this oxygen atom from the bond. That's what it started with after all. And it's 1, 2, 3, 4, 5, 6 valence electrons, just like it started with. Is what an atom has. Therefore, no charge on that oxygen. Here, however, let's do the same thing. 1, 2, 3, 4, 5. We're 1 short. That's a positive charge. Here, 1, 2, 3, 4, 5, 6, 7. That's too many. That's a negative charge. Well, ozone is uncharged overall. And that makes sense, plus minus. The Germans call this a Zwitterion with a W, meaning an internal salt. I don't think this compound is salty at all. I think this is a limitation of Lewis structures, but at least we have something that makes mathematical sense. It is O3. It's overall uncharged. You may not be thrilled about these positive and negative charges, but at least it works for us. It is an uncharged molecule. No net charge, yay. This is the carbonate dianion. Let's analyze each part of it. That's garden variety oxygen. 1, 2, 3, 4, 5, 6. That is too many. My dots might be hard to follow there, but there's 7 of them. 6 of them plus 1 from the bond. That makes 7. That's a negative charge. That one also negative charge. This one is fine, but can you see the error right there? My apologies. That should be a 4, right? Carbon has 4 valence electrons. They all come from the bonding single electrons there. There should be no charge there. -1 plus -1 makes -2, and the carbonate is -2. Fine, that's formal charge. Hydroxide anion, that should be pretty straightforward. Just draw it pretty close. You're never going to get away with a double bond. I mean, the hydrogen would look so weird if you did that. But give it 3 lone pairs rather than its 2 normal ones, and you should see that the negative charge is centered on that oxygen. Nitrate, NO3 minus. That's a good exercise. This is the correct Lewis structure. Notice that the central nitrogen is short one, right? It's all bonding electrons. There's only 4 of them, and it should be 5. I'd put a +1 charge right there. I hope I did somewhere, because otherwise this looks like NO3 2 minus. Confirm that you agree with these other charges. Yep, yeah, we're missing a positive charge right there. So that's the nitrate anion. And the ammonium cation, well, just draw all single bonds and no lone pair for the nitrogen, and you should see that you're short one in the center, and that is NH4+, the only common polyatomic cation, the ammonium cation. This is formal charge.